Hey guys, I'm going to read to you days 15 and 16 review book Earth Science assignment, pages 137 to 142. And while I read, I'm going to be underlining important information and making some text annotations. Atmospheric moisture. Atmospheric moisture, water, exists in three states of matter: liquid, solid, and gas. Gaseous water in the atmosphere is called water vapor. So I'm just going to kind of write that over here. So water is in three states: liquid, solid, or gas. They said gas is called a water vapor. Moisture in the form of water vapor enters the atmosphere by evaporation, sublimation to a gas, and transpiration. Evaporation is the process by which a liquid changes to a gas. Transpiration is the process by which plants release water vapor as part of their life functions. Collectively, evaporation and transpiration are called evapotranspiration. Sublimation to a gas is the process by which ice changes directly to water vapor without forming any liquid water. Energy of evaporation and transpiration of water. Large amounts of energy, approximately 2,260 joules per gram, are required to change liquid water into water vapor during the processes of evaporation and transpiration. Almost all of this energy comes from insolation. The solar energy is converted into a type of potential or stored energy in the water vapor. When evaporation or transpiration occurs, the more energetic water molecules leave the liquid and form water vapor. Since the molecules leaving the liquid are the more energetic ones, the average kinetic energy of the molecules remaining in the liquid decreases. As a result, the temperature of an evaporating liquid is somewhat lower than its surroundings. You have noticed this effect of evaporation when you step out of a shower and you feel chilled. Process of evaporation. Figure 7.11 helps to explain what happens when water or any other liquid evaporates. Diagram A shows a closed container of A into which some water has just been added. We assume there are no water vapor molecules in the air at this moment. However, as soon as water is placed in the container, some of its more energetic molecules begin to escape into the air above and mingle with other gas molecules that are present. Diagram B shows the situation in a short time later. There are water molecules in the air. We see two more molecules in the process of leaving the water. However, one molecule in the air is about to enter the water, so that there will be 5 molecules in the air. Diagram C shows the situation sometime later. There are now 8 water molecules in the air. Again, 2 more water molecules are about to leave the water, but now 2 molecules in the air are about to return to the water. The net result will be 8 molecules into the air, the same as before. We have a condition of dynamic equilibrium, in which the rate at which water is entering the gaseous state, evaporation, equals the rate at which the water vapor is returning to the liquid state, condensation. Factors affecting evaporation. Rates of water. The net evaporation rate of water at a location is determined by amount of energy available. The more energy available, and thus the higher the temperature, the faster evaporation of available water. Surface area of the water. The more spread out the water, the greater the air-water interface, and the faster the evaporation. Degree of saturation of the air with water vapor. The higher the water vapor content of the air, the closer the air is being saturated with water vapor, and the slower the net evaporation rate. Wind speed. Wind often moves air at the water-air interface that is high in water vapor and replaces it with air that is less saturated, and thus speeds up evaporation rates. The greater the speed of the wind, the more air replacement occurs. Humidity, temperature, and dew point. Like moisture, humidity is a general term that refers to water vapor content of the atmosphere. The amount mass of water vapor in each unit volume of air is called the absolute humidity. Absolute humidity is often measured in grams of water vapor per cubic meter of air. The maximum absolute humidity or moisture capacity increases rapidly with an increase in air temperature, as shown in the graph of figure 712. This means the total amount of water vapor the air can hold, its capacity, increases with an increase in temperature, or in other words, hotter air can hold more water vapor than colder air. Oh, that's interesting. Hotter air holds more water vapor than colder air. The ratio of the amount of water vapor in the air, absolute humidity, to the maximum amount it can hold, its moisture capacity, is relative humidity. It is usually expressed as a percent. In simpler terms, relative humidity is the amount of water vapor in the air compared to the amount of water vapor the air can hold at a specific temperature. The closer the absolute humidity is to the maximum absolute humidity capacity, the higher the relative humidity. Note the relative humidity is a percentage of saturation, or capacity, not how much water vapor there is in a volume of air. Relative humidity and temperature. At any given time and place, the air has a certain amount of water vapor, humidity, with a corresponding absolute humidity. If the temperature of the air changes but the amount of water vapor remains the same, the relative humidity will change. For example, if the temperature increases, the relative humidity will decrease. This occurs because the capacity increases with the increase in temperature. While the absolute humidity remains the same, on the other hand, if the temperature decreases while the absolute humidity remains the same, the relative humidity will increase. If the temperature of the air remains constant, but more water vapor is added to the air by evaporation or transpiration, both the absolute humidity and the relative humidity will increase. The relative humidity increases because the air becomes closer to its capacity or saturation point when more water vapor is added. Dew point. If the temperature of the air decreases while the absolute humidity remains the same, the temperature will eventually reach a point at which the absolute humidity equals capacity. At this temperature, the relative humidity will be 100%. This temperature is called dew point, the temperature at which air is filled with water vapor. If the air temperature drops below the dew point, water vapor in the air will condense to liquid water or sublimate to a solid. The dew point depends on the absolute humidity and not the relative humidity. As the amount of water vapor in the air increases, the dew point also rises because the more water vapor in the air, the closer the air is to saturation point, the dew point. Measuring relative humidity. Relative humidity is measured by indirect methods. Two similar instruments are commonly used to help measure relative humidity: a sling psychrometer and a hygrometer. Figure 713 shows these two instruments. Both use two thermometers. The instruments contain an ordinary thermometer called a dry bulb thermometer and another thermometer with a wick around its bulb called the wet bulb thermometer. With a sling psychrometer, when the wick is moistened and thermometers are whirled in the air, the temperature of the wet bulb drops because of the cooling effect of the evaporation of the water. The amount of cooling depends on the rate of evaporation and is therefore related to the relative humidity. To determine the percent of relative humidity, use the relative humidity percent tables in the Earth Science reference tables in the following procedure. Locate the dry bulb reading on the left-hand side of the relative humidity percent chart. Subtract the wet bulb reading from the dry bulb reading. Locate the difference between the wet bulb and dry bulb readings across the top of the chart. Follow the horizontal row for the dry bulb reading to the right until it meets the vertical column running down from the top. This number is the relative humidity. See 714 for an example for determining relative humidity. Determining dew point. To determine the dew point, you need the dry bulb and wet bulb readings from a sling psychrometer or a hygrometer and a dew point temperature chart in the Earth Science reference tables. Use the following procedure, which is very similar to the procedure used to determine the relative humidity. Locate the dry bulb reading on the left-hand side of the chart. Subtract the wet bulb reading from the dry bulb reading. Locate the difference between the wet bulb and dry bulb readings across the top of the chart. Follow the horizontal row for the dry bulb reading to the right until it meets the vertical column running down from the difference between the wet bulb and dry bulb readings. This number is the dew point temperature. For example, suppose the dry bulb reading is 8 degrees Celsius and the wet bulb reading is 6 degrees Celsius. The difference is 2 degrees Celsius. Reading across from 8 degrees Celsius and down from 2 degrees Celsius, you find a dew point temperature of 3 degrees Celsius. Cloud formation. If the temperature of the air cools, often by expanding, below the dew point, the water vapor will usually condense to a liquid or sublimate to a solid, changing to microscopic liquid water droplets or ice crystals, respectively. At Earth's surface, condensation produces liquid dew, and sublimation produces the solid frost. If the temperature in the atmosphere is above 0 degrees Celsius, condensation produces water droplets, which appear as a cloud when grouped. Some clouds are composed of ice crystals, which form when water vapor sublimates to a solid. A cloud is therefore a collection of liquid water droplets and/or ice crystals suspended in the atmosphere and dense enough to be visible. If there is only a low density of water droplets or ice crystals, a condition called haze may result. Cloud cover, found on some weather maps, is the fraction or percent of the total sky at a location that is covered by clouds. If a cloud is on or just above Earth's surface, it is called fog. The condensation or sublimation that forms clouds and fog releases tremendous amounts of energy into the troposphere. This is the potential energy that was imparted to water molecules during evaporation and sublimation to a gas. Besides needing saturated air, condensation usually requires a surface upon which the vapor can condense. This is called the condensation surface. In the formation of clouds and fog, the condensation surfaces are aerosols such as dust, bacteria, and volcanic ash. In the formation of dew, the condensation surfaces are the features of Earth's surface like grass and leaves. Since air temperature and dew point temperature both decrease with altitude in the troposphere, the altitude when temperature and dew point are the same is the level where clouds form by condensation or sublimation. This level is often seen as the flat bottoms of some clouds. Precipitation. The falling of liquid or solid from clouds toward the surface of the earth is precipitation. For precipitation to occur, the ice crystals or water droplets in clouds must come together to become big enough so that they will fall under the influence of gravity. The forms in which precipitation occur are rain, drizzle, snow, sleet, freezing rain, and hail. The conditions that result in the formations of these different types of precipitation are shown in Figure 7.16. A rain gauge, a type of precipitation gauge, is used to measure liquid precipitation. It is measured in depth, usually inches or centimeters. Snow depth is often measured with a ruler or is gently warmed, and the depth of the liquid is measured and reported as precipitation. A rain shower is brief, rapidly forming, rapidly ending, and often heavy rain associated with the thunderstorm-type clouds. A snow shower is a brief, heavy snowfall. To review, precipitation usually occurs when rising air cools portions of the troposphere. This action reduces the differences between air temperature and the dew point temperature until the water content of the air equals the air capacity to hold water vapor. If the air continues to cool below the dew point, liquid water droplets by condensation or tiny ice crystals by sublimation deposition form, usually producing clouds. When these liquid or solid cloud particles collide or otherwise combine, they become heavy enough to fall, producing precipitation. The factors that cause the rising air and this cooling are upward movement of air at fronts, air blowing against a mountain, or portions of the air that's selectively heated at Earth's surface, such as over a dark road. Atmospheric transparency and precipitation. The more pollutants added to the atmosphere by the activities of people and the nature, the more aerosols are present. The more aerosols in the air, the less transparent the atmosphere is to insulation. How transparent atmosphere is to insulation is called atmospheric transparency. When the atmosphere is less transparent, it means that more energy from the sun is absorbed or reflected by the atmosphere, resulting in less insulation reaching Earth's surface. When the atmosphere has an aerosol content so high the distant images are blurred and a cloudless sky does not appear blue, the condition is called haze. A haze or fog, usually brownish, which is highly polluted, is smog. So polluted fog equals smog. Condensation and cloud formation incorporate some of the aerosols, and these aerosols are removed from the atmosphere during precipitation. The falling liquid or solid water also collects other aerosols on the way down, thus lowering air pollution levels and cleaning the atmosphere. Visibility, sometimes found on weather maps, is how far you can see along Earth's surface, expressed in miles. The poorer the atmosphere transparency, the lower the visibility. Number 36. As altitude within the troposphere increases, the amount of water vapor generally decreases only, increases only, remains the same, or decreases then increases. By which process does moisture leave green plants? Convection, condensation, transpiration, or radiation? Most moisture enters the atmosphere by the process of convection and conduction, condensation and radiation, reflection and absorption, transpiration and evaporation. Number 39. The primary source of most of the moisture in Earth's atmosphere is soil moisture storage, rivers and lakes, melting glaciers, or oceans. As the exposed area of a moist object decreases, the rate of evaporation of the liquid from that object decreases, increases, or remains the same. As the amount of light energy striking a moist object increases, the rate of evaporation of the liquid from that object decreases, increases, or remains the same. Number 42. As the amount of water vapor is given in a given volume of air increases, the rate of evaporation from a moist object decreases, increases, or remains the same. Number 43. There will most likely be an increase in the rate at which water evaporates from the lake if there is 1. A decrease in the temperature of the air. 2. A decrease in the altitude of the sun. 3. An increase in the moisture content of the air. Or 4. An increase in the wind velocity. Number 44. In the following diagram, at which location would the amount of water vapor in the air most likely be greater? A, B, C, or D? 45. In the closed aquarium shown in the following diagram, the amount of water evaporating is equal to the amount of water vapor condensing. Which statement best explains why these amounts are equal? 1. The glass sides of the aquarium are warmer than the water. 2. The air in the aquarium is 50% saturated. 3. The relative humidity outside the aquarium is 100%. Or 4. The air in the aquarium is saturated. Number 46. Which graph best represents the relationship between the moisture holding capacity of the atmosphere and the atmospheric temperature? 47. To say the relative humidity on a given day is 70% means that the air, 1. is composed of 70% water vapor, 2. holds 70% of its water vapor capacity, 3. holds 70 parts of water to 100 parts of dry air, or 4. contains the same amount of water that it would contain at 70 degrees Fahrenheit. Number 48. If the amount of water vapor in the air increases, then the dew point of the air will decrease, increase, or remain the same. During which part of the day is the relative humidity usually lowest? 1. morning, 2. mid-afternoon, 3. evening, or 4. late night. 50. As the air temperature rises, the relative humidity increases, decreases, or remains the same. Number 51. Air with a temperature of 60 degrees Fahrenheit and a relative humidity of 51% was warmed to a temperature of 70 degrees Fahrenheit, but the relative humidity remained at 51%. How did the moisture content change? The moisture content decreased, the moisture content increased, or the moisture content remains the same. 52. Which statement best explains why the wet bulb thermometer of a sling psychrometer usually shows a lower temperature than the dry bulb thermometer? 1. Water evaporates from the wet bulb thermometer. 2. Water vapor condenses on the wet bulb thermometer. 3. The air around the wet bulb prevents absorption of the heat. Or 4. The air around the dry bulb prevents absorption of heat. 53. When the dry bulb temperature is 20 degrees Celsius and the wet bulb temperature is 16 degrees Celsius, the relative humidity is 42%, 62%, 66%, or 69%. 54. The dry bulb temperature is 20 degrees Celsius. The wet bulb temperature is 17 degrees Celsius. What is the dew point? 1. 12 degrees Celsius, 13 degrees Celsius, 14 degrees Celsius, or 15 degrees Celsius. Base your answers to questions 55 and 56 on the weather instruments shown in the following diagram. What are the equivalent Celsius temperature readings for the Fahrenheit readings shown? 1. Wet 21 degrees Celsius, dry 27 degrees Celsius. 2. Wet 26 degrees Celsius, dry 37 degrees Celsius. 3. Wet 70 degrees Celsius, dry 80 degrees Celsius. Or 4. Wet 158 degrees Celsius, or dry 176 degrees Celsius. 56. Which weather variables are most easily determined by using the weather instrument on the Earth Science reference tables? 1. Air temperature and wind speed. 2. Visibility and wind direction. 3. Relative humidity and dew point. Or 4. Air pressure and cloud type. 57. Which process most directly results in cloud formation? Condensation, transpiration, precipitation, or radiation? 58. At which temperature could water vapor in the atmosphere change directly into solid ice crystals? 20 degrees Fahrenheit, 40 degrees Fahrenheit, 10 degrees Celsius, or 100 degrees Celsius? Which statement best explains how atmospheric dust particles influence the water cycle? 1. Dust particles are the main source of dissolved salts in the sea. 2. Dust particles increase the capacity of the atmosphere to hold water vapor. 3. Dust particles increase the amount of evaporation that take place. Or 4. Dust particles provide surfaces on which water vapor can condense. Number 60. Atmospheric transparency is most likely to increase after volcanic eruption, forest fires, industrial activity, or precipitation.